Hello students, in today's class of chemistry, we'll talk about this topic of chemical bonding named excitation. Okay, so this falls under the topic valence bond theory, in which we have already studied that in order to form a bond, two orbitals of two atoms should overlap. They can form sigma bond or pi bond, as we have studied in valence bond theory. Okay, so what is excitation is the promotion of electron from a lower energy level orbital to a higher energy level orbital. Okay, so it is an endothermic process, obviously, because you have to go from this level to this level. So it will need this amount of energy. Okay, endothermic process. This energy that we require, or the molecule in order to form requires, is provided generally at room temperature by thermal energy, but in some cases it is not available. This energy is not available, and hence electron cannot jump to the higher energy level. And that's why we have a few conclusions. That is what we are going to talk about in this lecture, and we will be able to answer the question that why nitrogen cannot form 5 bonds. We know that nitrogen has 5 electrons in the valence shell, yet it cannot form 5 bonds. Why? That we'll understand in this topic. Also, phosphorus, we know that it can form 5 bonds. It can form 5 bonds. For example, PF5, PCl5, we know that. But 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 PH5, PH5 does not exist. Does not exist. Why? This is the objective of today's lecture, to understand why nitrogen cannot form 5 bonds with any of the side atoms, and why phosphorus selectively does not form 5 bonds with hydrogen, but it can form 5 bonds with atoms like fluorine and chlorine. So let's start the excitation. Okay, excitation, as I said, is promotion of electrons to higher energy levels. Higher energy levels. Okay, promotion of electrons to higher energy level from a lower energy level orbital is called uh, excitation, and it is endothermic. So energy is obviously required. Energy is required. Okay, so let's consider a basic example of CH4. Okay, CH4, carbon, we know it has valence shell electronic configuration of 2s2 and 2p2. 2s2 2p2 is the valence shell electronic configuration of carbon. And if we can draw the orbitals s and p here, we can see that 2 electrons are present in 2s orbitals and 2 electrons are present in 2p orbitals. Now we know that as per the basic elementary knowledge of valence bond theory, we are going to overlap the orbitals in order to form bonds, or we can say that one electron from one orbital and one electron from another orbital are going to be paired, and one single bond will contain 2 electrons. Okay, so that orbital which is unpaired, basically which is having only one electron, that is going to form the bond. So also we know that carbon forms 4 bonds. Okay, we can see here that there are 2 electrons only that are present, which are unpaired. So what happens here is this electron from 2s orbital jumps to this p orbital. Okay, now there is certain amount of energy gap. This is energy gap. I have drawn it on the same level for understanding purposes, but there is energy gap. This is 2s and this is 2p. Okay, so there should be some energy gap associated between s and p orbitals. So electron jumps from 2s to 2p, and the excited state, we can say this is carbon in excited state, it becomes 2s1 and 2p3. 2s1 and 2p3. One electron goes from 2s to 2p. Okay. Now we can see that there are 4 orbitals which are having only one electron, and hence carbon can form 4 bonds. And we can see carbon forming 4 bonds from CH4 to CCl4 and many other cases in organic chemistry. Okay. One thing also we can understand here is that here we can say that S forms one bond and P forms three bonds, but this is also not factually correct. That we'll know about in the concept known as hybridization, in which we'll discuss that pure orbitals actually do not form bonds, sigma bonds, and what happens is these orbitals first combine in order to form separate in order to form some hybrid orbitals, and these hybrid orbital actually are going to form bonds for us, for the molecule. Okay, so this is carbon and this is the excited state of carbon. Electron is going from 2s to 2p, and everything is fine because that energy level is the energy gap is very low. Energy gap is low and it is accessible at room temperature. Hence, the electron can go from 2s to 2p in case of carbon. Okay, so we are getting two conditions for excitation. What are the two conditions for excitation? First is there should be vacant orbital, no? At higher energy level there should be orbital so that electron can go. Okay, if there is no orbital here, electron cannot go. Okay, so that's why the first and foremost condition for excitation is there should be vacant orbital. There should be vacant orbital present at higher energy level. Okay, and the second is this, that the energy gap should be accessible. Energy gap should be accessible. The energy gap should be low, you can say, or you can say it is accessible. Okay, it can be fulfilled at room temperature by thermal energy. Okay, so these are the two primary conditions for excitation. Now let's take the example of nitrogen and phosphorus, for which we are going to understand how or why 5 bond can or cannot form. This is valence shell electronic configuration of nitrogen 2s2 and 2p3, and for phosphorus it is 3s2 and 3p3. Okay, so in nitrogen we can draw like this, 2s2 2p3, and in phosphorus also we can draw 3s2 pp3, and there is also something called 3d in phosphorus only because it is from the third period. So the 3d orbital is vacant in case of phosphorus. Okay, so that is available and it is vacant. 3d 0. Okay, you can also 3d 0, 3s2 3p3 3d 0, because in third shell there is d orbital present, but in second shell there is no d orbital present. Okay, so we cannot write 2d. Okay, so here what happens is, if we want to excite the electron, this is the paired electron, no? This we have to excite to the higher energy level. Okay, but there is no vacant orbital present. There is no vacant orbital present, or simply what we say is d orbital is not present. There is no d orbital present in the second shell. Hence, there cannot be any excitation that will be taking place in case of nitrogen. So the excited state of nitrogen will also look like this only. It will form bond in this configuration only, because there are no orbitals that are available for the electron to go at higher energy level. That's why no excitation, because the primary condition was the availability of vacant orbitals. Okay, nitrogen fails in the first criteria only, and hence nitrogen cannot promote electron. Nitrogen cannot promote electron to higher energy level, and hence we are going to see only three. Unpaired electrons, and hence in normal conditions nitrogen can form only 3 bonds. Okay, but it can also form 4 bonds if it is going to donate this lone pair. Then it can form a coordinate bond, which we have already studied. What is a coordinate bond? When one atom only donates both the electrons in a covalent bond, then it is called a coordinate bond. So nitrogen can form one coordinate bond here and 3 proper covalent bonds here. So it can form maximum of 4 bonds. So maximum bonds for nitrogen is equal to what? It is 4. It can form maximum 4 bonds. Okay. And normally it forms 3 bonds. This is the case of nitrogen. Hence, we can say that NF5, NH5, NCl5, or any other molecule in which nitrogen is forming 5 bond cannot exist. It will not be formed, and hence these do not exist. Okay. So now let's take the example of phosphorus. Phosphorus, we have 3s2, 3p3, and 3d 0. Okay. So the 3d orbital here is vacant. Okay. Vacant. Now, what was the problem in nitrogen has been solved here. Okay. There was no vacant orbital, but here there is vacant orbital present, but there is also one second condition, no? That energy gap should be accessible. Now let's analyze about the energy gap. Energy gap between s and p orbitals is generally low and accessible. That we can see in case of carbon also. So that was accessible. But in case of phosphorus, the electron has to go from this 3s to this 3d orbital. 3s to 3d orbital. It has to go. This is 3s and this is 3d, and the energy gap here is not very low, and it is generally not accessible. It is generally not accessible. Okay. It is generally not accessible. So how can phosphorus, or will phosphorus form 5 bonds? Let's see. Now what we can do is we can make it accessible. Okay. How can we make it accessible? By some sort of contraction. Okay. Contraction, we can contract the d orbital and s orbital like this, and hence the energy gap will be lower, and it can fall under the accessible energy gap region. Okay. So how can we contract? So here comes the phenomenon called charge contraction. Charge contraction. What charge contraction tells us is, this is phosphorus neutral. Let's suppose this is the size of phosphorus. But if phosphorus contains delta plus charge means slightly positive charge. Slightly positive charge means the atom that is connected to phosphorus is more electronegative. It is pulling the electron density from the bond from phosphorus, and hence phosphorus is getting delta positive charge. Delta positive charge means phosphorus, the effective nuclear charge on phosphorus increases, and hence the size of phosphorus slightly decreases. So if delta plus charge comes on phosphorus, the size will decrease, and hence what happens on when size decreases is, this is the 3s orbital and this is the 3d orbital in case of normal phosphorus. But if size decreases, the orbitals contract. So the contraction of 3s orbital is not very much because it is already very close to the nucleus, but 3d orbital, it gets contracted very much, and hence the energy gap decreases considerably, and this energy gap now becomes accessible. This energy gap now becomes accessible energy gap. So what we have learned is, if there is some atom which is joined with phosphorus, connected with phosphorus, which is having greater electronegativity, then it will create a delta positive charge on phosphorus, and the delta positive charge that is created on phosphorus will do what? It will do a charge contraction phenomenon, which will make the delta E, the energy gap, accessible energy gap for the promotion of electron. Okay. So now come back to the phosphorus orbitals. Okay. If the energy gap becomes accessible, then the promotion can take place. The promotion 3s1 pp3, and it will become 3d1. Okay. So this is the excited state of phosphorus, but what we are considering is, there is delta positive charge associated with phosphorus. There is charge contraction taking place. That means there should be the side atom. The side atom, it should be more electronegative. It should be more electronegative. Side atom should be more electronegative. And hence, if side atom is more electronegative, charge contraction will take place, energy gap will become accessible, and promotion of electron is possible, and 5 orbitals will be having unpaired electrons in order to form sigma bonds or in order to form bonds. Okay, so phosphorus can form 5 bonds, okay, only if the side atoms are electronegative. But what we can say is hydrogen is hydrogen is not sufficiently hydrogen is not sufficiently electronegative. It is not sufficiently electronegative. Hence pH5 does not exist. Hence pH5 does not exist. So let's conclude. Okay, so what we were trying to achieve in this lecture was uh, why nitrogen cannot form 5 bonds. So nitrogen cannot form 5 bonds due to unavailability of vacant orbitals. Unavailability of vacant orbitals. Okay, means 2d orbitals. There are no 2d orbitals present. Hence, nitrogen cannot form 5 bonds. Okay, it can form maximum of 4 bonds, which contains one coordinate bond. Whereas phosphorus, it can form PCl5. Yes, it can form PF5. Yes, but can it form PH5? No. Why? Because hydrogen is not sufficiently electronegative, and we have two conditions for excitation. First condition was availability of vacant d orbital that is present in phosphorus in the form of 3d 0, but the second condition, which was accessible energy gap, that is not present in phosphorus. Energy gap is not accessible. It can be made accessible by using more electronegative side atoms, for example chlorine, fluorine, etc. But hydrogen, not being sufficiently electronegative, it cannot create delta positive charge on phosphorus. Hence charge contraction cannot take place, and hence phosphorus cannot form 5 bond in case of phosphorus. And phosphorus can only form PH3 with hydrogen and not PH5. Okay, so I think that all of you have understood this topic called excitation, and we can relate this topic to find out whether any molecule exists or not in some cases. For example, we have seen some molecules. So I hope you enjoyed the lecture. Thank you.